वो बंद हमें करना है? Right. हो गया ना? Professor Baker says it's just 10:28. So एक बार राजेंद्र जी को मैसेज कर दीजिए, चेक कर यूट्यूब कितने लोग पहला वाला मैसेज दे दीजिए। हाँ यूट्यूब में देना था। Yes, done, sir.
Okay, okay.
10:30 and मैसेज कर दीजिए। 9 watching. Sir, 31. Professor PK, should we? Thank you. Good morning. Very warm welcome to everyone joining us today. To begin the session, I would like to invite Dr. A.V. Balachandar to deliver the introductory remarks. Sorry, sir.
So, good morning to everyone. So, today we are here for the third session of the Lightning Talk series of our PMECRG awardees, which we have initiated 2 months back. And today we are very much uh, going to go look forward to the different awardees. So we're going to talk about mainly focusing on earth and atmospheric sciences. So as you all know that the PMECRG Early Career Award scheme is to empower and support the early career research to the pursuit of the research excellence. So the purpose of the scheme is to enable the environment so that they encourage the young investigator to start the research career with a high quality research with the ease and flexibility and as well as the independence of the firm. So in the first year, we have nearly supported 700 researchers across a wide spectrum of scientific field and to take this bold and innovative approach to address the critical challenges which can contribute in advancing our national priorities. So in this session, we have three PMECRG awardees, which are from Earth and Atmospheric Sciences. The first one is Dr. Uh, John, Dr.
Jagdish.
Out from Department of Geography, Ravenshaw University, Qatar, Odisha. Her specialization is in aquatic vegetation distribution and remote sensing application and also the water quality assessment. Next one is Dr. Lakshmi Narayan. We prefer to call as Dr. Laksh. As an assistant professor in environmental studies at the University School at Interwoven Arts and Science. So, in area of specialization is atmospheric and space physics. He focuses on air flow imaging, ionospheric studies, and development of open scientific instruments. So next one is Dr. Goswami, so whose research is focused on finding principled and methods to drive a low representation of the climate and on developing a data-driven models to predict the weather patterns from a long time to a seasonal scales. So with this, I invite Professor Ponurangan Kunduru, who's the moderator of today's session. So as you all know that if you all aware of Sarah Ray, so he is the man behind that creation of that app. He's a professor of computer science at IIIT Hyderabad. Has its areas of expertise spans a responsible AI, applied machine learning, and natural language processing. Sir, now I request you to take over that meeting, sir. Please, sir.
In the order of first Bharatha, then Yanasevi, and then Narayanan. In that order, please keep your sort of say content between 8 to 10 minutes. Let's get started, Bharatha. And for those listening in on YouTube, please put your questions on YouTube. I will moderate the questions. I will look at the questions, take the questions, bring it to the session here as the speakers finish. If there are any immediate questions, we'll do it as part of the session when the speaker is doing the content. But otherwise, we'll finish the entire content, which is about 36 to 40 minutes. Each of them will do 8 to 10 minutes. So 30 to 35 minutes, we should be able to finish all the content. And then we'll do a very good deep question answering session. I also have some questions. I'm sure we'll ask some questions as we from the audience also. So let yours. All right. Thanks. Thanks, Professor BK, for putting this together and for giving me this opportunity to present the work that I'm doing under this ANRI funded project, the PMECRG. So in the next 8 to 10 minutes, I'll try to give you a flavor of what deep learning or machine learning and popularly called AI models, these kind of weather models, how they work, and what do we need to do sort of to make them applicable for South Asia. So that's the broad focus of my project and also a large part of this talk. Before that, just to give you a brief overview of my research trajectory so far. So I am currently an assistant professor at ISER Pune, but I also graduated from this. So I returned back to my alma mater. I did my PhD in the Potsdam Climate Research Institute, and then I was a group leader at the University of Tübingen. In the last 15 years or so, I've been broadly working on complex systems, mainly focused on climate data analysis. And the last 8 years or so, I've been focusing on machine learning for weather and climate. All right, moving into the talk. So in this first part, in the next 3 to 4 minutes, I'll try to give you a flavor of what do I mean by deep learning weather models. First, let's just look at this. This is a kind of a scorecard. You can think of this as a leaderboard of different weather models performing for different atmospheric variables. You have temperature, surface pressure, you have wind speeds, you have rainfall, and each row corresponds to a different model. The top row is the kind of our reference model, which is physics-based, the top two rows. And then you have all these models, Pangu Weather, GraphCast, GenCast, Aurora, FGN. These are deep learning-based AI weather models. And basically, what I want you to take home from this is that blue is indicates that the model in question for that particular variable at that forecast lead time performs better. Blue means you performs better than the physics-based model, and red means you do not perform better than the physics. You're worse than the physics-based model. And you see that GraphCast, GenCast, Aurora, FGN, most of these deep learning weather models, they are actually outperforming the physics-based models. So you have very deep blue colors for quite a few of the variables. Um, this is basically to motivate that this is a kind of an alternative approach to modeling the weather as opposed to the classical physics-based approach, and this is here to stay. They are outperforming the physics-based approaches. Just to highlight this contrast, underscore this contrast a little bit more. So this is a very informative plot here on the left from this paper from 2015, where this paper was called The Quiet Revolution of Numerical Weather Prediction, so physics-based prediction, which basically shows the performance, the forecast skill increasing. Basically the weather models, what this graph shows is that the weather models have been getting better and better from 1981 to 2013. And but the point to note here is that this getting better has been an incremental process. It's very challenging. It's a lot of work has gone into it, but it has been incremental. That's the history of physics-based weather models. They're also CPU-based, and uh, inherently structurally you find that these models to issue the forecast, it requires a lot of computation. On the other hand, if you look at deep learning weather models, they're very new. This is a very new idea. This is I've shown you a screenshot here from one of the first papers which just conceptually tested out this idea, can we use deep learning based models to predict the weather? And that was from 2019. And already then 4 years later in 2023, we have these first headline papers, releasing GraphCast and Pangu weather, which already started to outperform in the span of 4 years. So we've seen rapid progress in this field, and of course, again, just to highlight the contrast, these models tend to be GPU based, and to issue a forecast from a deep learning weather model, the forecast estimation is quite cheap. I mean, it takes some GPU computation to train these models, but once they are trained, forecasts can be just done on a state-of-the-art laptop, and you don't need a fancy high-performance cluster to issue a forecast as opposed to the physics-based models. So this is just to give you a flavor of the trajectory of these models so far. And how do these models predict the weather actually? So they don't use physics, so what do they do? And this is basically done as with most machine learning and deep learning approaches. So you have some training data, and I'm basically quoting some numbers here from a standard benchmark called Weather Bench, where you have around 40 years of training data, 6 hourly global data, and you have lots of variables going from the surface to different levels of the atmosphere. So you have 5 surface and 65 upper variables. So around 70 different variables over 40 years at high resolution. And what you do is you basically train a model to take the current weather state and predict the next state. And once you predicted the next state, you can feed it back into the model and predict the next, and then the next, and then the next. And that is how you sort of train these models to predict the weather. Um, just to give you a schematic intuition of how these models have these upper air variables and surface variables that pass to the model and spit out the next. What, uh, last week actually, and this talks about the terrible devastation that Cyclone Ditwa caused in Sri Lanka. And he makes this very important point, which is a bit nuanced, and I'd like to highlight this here in this quote, is that actually, if you look at these cyclones, they were not the strongest storms. So they were not really like, had hurricane levels of like, wind speeds. But what was special about these storms is that they carried huge amounts of water, which is very abnormal. And this is the sort of future that we're looking at, right, given ongoing climate change. And and what I want you to sort of take home from this slide is that, like, we are moving into a future where we'll be looking at storms with more and more rainfall. So we do need weather models that really predict rainfall quite well. Uh, and then if you go back to the scorecard, you find that for precipitation, the weather models don't do so well. And in fact, some of the weather models like Pangu and I would focus on. So here's my sort of wish list for what we need for South Asia. We need models that predict rainfall. We need to be able to have models that capture extreme rainfall. And we also need well-calibrated rain models. So well-calibrated predictions essentially means that your model is sure if it tends to issue a correct prediction, and if it's unsure if it's a wrong prediction. And we also need to have long-term forecasts beyond 14 days. All right, so I just have a couple of slides about the project details. So my research agenda, so this is what I've been building up to, is to develop baselines, fine-tune existing models, the GraphCast, Pangu, and so over South Asia to establish a baseline. And on top of this baseline, develop a generative model, a probabilistic model for South Asia that can use, longer time periods from the past to predict rainfall and make it high performing for rainfall. One thing which I am personally very excited about is the model has open source and open access. Outcomes of deliverables of this project are, that will basically provide a new way of how to use long context and how to sort of couple the atmosphere and ocean in the deep learning model, which is still, it's very frontier. But there aren't too many papers out there which have tried this. And again, just to drive home, I think it would be really cool to have a homegrown weather model, deep learning weather model from India. Societal impact, if we are able to issue reliable extreme weather forecasts and long-term forecasts beyond 14 days, that would be really good. I also think it's really important that if we actually have an open source model, then if we try to make it lightweight, not too big, local research groups can actually gain from this and build upon it as well. All right, that's all that I have for you today. Thank you for your attention. And these are the different ways that you can reach out to me: email, LinkedIn, X, GitHub. That's my website. Especially students, PhD applicants, postdocs. If you're interested, if you think you like deep learning, and if you think you want to do something for weather forecasting, feel free to reach out. Thank you.
Thanks, Vanita. I have some questions, but we can actually come back to questions when both other speakers are done. Anthony, can you share your screen and we can go with your content? Yep. Yeah. Thank you.
Thank you. I'm Jagisri from Ravenshaw University, Odisha.
Can you put it on slideshow if it's okay? Yeah.
Is it okay, sir?
Yeah, perfectly fine.
Okay. Thank you. I'm Jagisri from Ravenshaw University, Odisha. I'm grateful to NRF for the prestigious PMECRG grant for the 3 years project. And I'm very much thankful for getting help and guidance from also for all authorities of my university to execute this project. And today my topic is about quantifying to India's landscape transformation and remote sensing approach to human modification. And next, it is my education and experience till date. This is particularly my intermediate to post graduation. I studied at Ravenshaw College, which was built in the year 1868 in the name of King Ravenshaw, and who was a British administrator. Later on, the college upgraded to university, and I completed my MPhil and PhD from the same university, where I am working as assistant professor from the year 2022. After my post-graduation, I have done my remote sensing and the GIS course at IRS Dehradun. And before joining as assistant professor, I have experience in project working as a research project in IIT Odisha funded by the World Bank. And this is my research broader research area which spans hydrological and ecological systems, including wetlands, coastal, and the fluvial environments, along with basin and watershed management, environmental pollution process, and also climatic variable and the overreaching impacts of anthropogenic pressures on natural, basically ecosystems. And this is my recent publication which I got my PhD scholar, which motivates me for this project proposal. And next background of the basically the project proposal is the landscape transformation is happening in globally relating ecosystem, biodiversity, and also climate. And the study site is for my project is whole India, and the remote sensing offers a powerful means of capturing these changes over extensive spatial and temporal scales of different satellite imagery. And this is the physiographic map of India. Basically, 11 types of physiographic divisions are creating very complex understanding on environment and society. Due to these different types of environmental, social, and also economic losses are happening globally, like livelihood loss, displacement, and resource scarcity, cultural disruption, migration, etc. And these are my research questions for preparing the project proposal. And basically, number 4 are the basic questions. And my first objective is to quantify spatial human modifications across India from 2000 to 2025. And second objective is to integrate multiple remote sensing derived parameters into a comprehensive index of human modification. And the last one is to produce normalized weighted output map highlighting areas with low to high human modifications. And the novelty of the study is to basically identify the regions with the high ecological stress for targeted interventions and assisting urban planning and sustainable development and providing data for climate impact studies, which showing the human modified climatic zones and the integration of these all database and then all the nobilities, diverse indicators into a single modification for an unprecedented view of India's anthropogenic transformation was guiding future research, policy, and also for conservation efforts. And these are my database which will be used for the project, implementing the project. The number one, there are basically the DAME database, and here is the data set, resolution, and the availability of data. Then first one, the DAME database will be used for analyzing topographic influence on settlements and environmental modification. And next is population growth is a direct driver of landscape transformation, leading to increased demand for land and also water resource, and it intensifies environmental pressures through waste generation, deforestation, and urban expansion. And the next, land surface temperature, that is known as LST, it shows the temperature variation of all areas. And next is the temperature reanalysis data, actually anomalies between observed and reanalyzed temperature data, which reflects the urban heat island due to industrial heat emission and also land use land cover change. And next is the land use land cover data is also a transformation from high resolution data. And next is the night light data, which will be used for as an indicator of human activity, urbanization, and also for infrastructure expansion. And next is urbanization and population data. Basically, it is a primary driver of land transformation, which leads and also higher emissions. And then normalized difference vegetation index, which is known as NDVI, and the trends are strongly influenced by deforestation, agriculture, and also urban expansion. And the last one is greenhouse gas emission, which shows the emission due to landscape transformation. And these are my methodology, sequence of the methodology from data acquisition to validation and sensitive analysis. After data acquisition, we should do a normalization process for each parameter 0 to 1 scale, where 0 represents low human modification and 1 represents high human modification. And also in index calculation, multiply each parameter by its respective weight and aggregate them to calculate a composite human modification index. And during the validation process, to validate all the data through ground truth data and also Google and satellite image, and perform a sensitive analysis to evaluate the impact of different parameter weights on the final index output. And the high resolution satellite data can be get from Planet platform, which is recently launched for this some specific area. And this is the flow chart, basically my methodology part. After the data normalization, we use to PCA techniques, which is principal component analysis, which is a quantitative technique, and analytical hierarchical process, which is HPG qualitative technique. And after that, machine learning, basically I have decided now to random forest method will be used. And after all the analysis, three techniques will be used, and then made a comparative analysis for the best results. And this is my expected outcome, which will be a spatially explicit map will be generated for human modification across India for the period of 2000 and 2025, and ranging from low to high modifications. And the research will be helped to identify hotspots of human impact and enable comparisons across region level, state level, district level, and also block level. And the study will be offer insights into how human activities have reshaped India's landscape, which will be aiding for policymakers and researchers in prioritizing areas for conservation and also for development. And this is where the societal impact, this is a concept map of the societal impact for the final hotspot map, and the output map can be used for different users like policymakers, researchers, managers, and also administrators for problem management in the field of risk identification, disaster preparedness, and resource planning, sustainable development, and then the resilience building also. And this is the students' opportunity for basically students under undergraduate and post graduation can join for internship for 6 months from the subject of geography, geoinformatics, and environmental science. And students can appeal the opportunity who have qualified UGC NET only, because it is a state, it is under UGC, and it is also a state university. And basically, it is my social site links. The students can connect with me, and with this, I'm concluding my presentation. Thank you. Have a nice day.
Thank you, Anasani. Narayanan, will go with yours.
Yes, thank you. I will share my slides. Do you see the slides?
Yes.
Is it in the presentation mode?
So we see our own screen faces.
I see. Okay, I'm not sure. Just try. Yeah, do you see it now?
Something is coming up.
Yes.
Yes. It's in presentation mode.
Yeah. Sorry for the mix-up here. Thank you very much. Myself, Lakshminarayan from Priya University, and we are located some 20 kilometers south of Sweden. If you want to learn the university, it's a university, like emerging institution. And I, first of all, I express my thanks to ANRF for awarding the grant and also providing such opportunities to highlight the research activities that we do. This is very important. Thank you very much. So my project title is Early Morning Ionospheric Thermospheric System. Their knowledge gaps and importance, why they are important to be understood. So I'm going to just give a brief overview. And my background, I did my PhD in Indian Institute of Humanism, and then I was an academic nomad for a decade, working in different countries. So now I'm back in AI University, and my specializations are atmospheric dynamics and atmospheric studies, space weather, and especially remote sensing. Now I'm moving more and more into remote sensing, low cost remote sensing techniques, development of instruments, and data analysis. So this is a very, very brief introduction to the atmosphere. What are the different layers of the atmosphere? And my interest starts from above stratosphere or well above troposphere. Of course, I also have to discuss a little bit about the stratosphere at times, but my primary interest is in the mesosphere and upper atmosphere. So if you see that as you move higher and higher and above 100 kilometers, the solar cycle plays a major role, and Sun is undergoing a 11-year cycle. So once in 11 years, Sun will be very active. We are at present in that period where we are getting impacted with high energy solar wind particles. You might have heard about Airbus software disruption due to solar storms and so long enough durations of the order of a few seconds and above about 60 kilometers, and that's what we call as ionosphere. Ionosphere and the upper atmosphere and middle and upper atmosphere, they coexist. It's not that ionosphere is a different region. And even at the peak of the ionosphere, the number of neutral gases always dominate. So ionosphere means it contains some charged particles, but that becomes important because of the electromagnetic forces, which are long-range forces. So the plasma will behave in a manner. And in this, I would like to bring to your attention some unique regions and why the area that I'm focusing is a very important transition region in the Earth system. So the meteors that come into the Earth typically burn between the altitudes of about 80 to 140 kilometers. And then the space debris that we enter will burn slightly below, kind of 60 to 80. And we still are not well aware of the ill effects or good things that space debris burning and the metals that are being deposited there will have. So that's one big area to be explored. And therefore, the region between about 50 to 300 kilometers is an important transition region where the neutral atmosphere and the weather kind of systems that we see is going to change into some plasma processes dominated geospace. So therefore, this is the buffer region and transition region that I'm interested in. And why ionosphere is important, to put it in a simple way, it's very, very important for radio communications and radio based applications.
Professor
If there was no ionosphere, the transatlantic radio communication, which brought humans came to Marconi. Dr. Raj, sorry, sorry for interrupting.
Yeah. Can you please stop and reshare your presentation once more? There was some problem.
Yes. Uh, so I think it somehow got. It's not.
But the Teams one we were able to see, no?
Do you
Yes.
see that now?
Yeah, yeah.
Now we can see it.
Now.
I can't see it though.
Oh, is it?
No, sir, not feasible.
I see. Okay. Maybe if you share your entire desktop, maybe that's a sometimes these things.
But how is it that I'm able to see it? But that's okay. Yeah, look, Narayana,
Yeah. So I'll do that. Probably I will. And Professor BK
share
may
the entire screen.
the
Sorry?
I'm sharing
What
the
is that?
screen.
Better is asking me something. Yeah, but
I think the difference is that you're using the Teams app, whereas I'm joining via browser, and I think Lakshmi is also on the browser.
oh,
Yes.
okay. Yeah, I'm
The browser.
now can you see the slides?
No, actually, no.
No, sir, no, sir.
Sumita, you?
No, sir.
No,
Not
now
on.
I share the whole screen. May leave and rejoin just in a moment.
Yeah, let's just do that. Let's just leave.
Yeah.
Let's drop the call and come back again. Sumita, you're also not able to see the slides?
No, sir.
Oh, okay. And why is it showing only to me then?
Other tools are good.
Sumita, you're also joining through a browser or the
Yes,
Teams
sir.
app?
Browser. It was working fine.
Okay. Yeah, Narayan, let's try again. You're muted, but let's try again.
Yeah, thanks for pointing it out. I'm trying to share again. Is it visible now?
No.
I can see it. So I'm not the right person to say, but yeah, people using the browser should say it.
No.
No, sir. No, sir.
Oh,
I'm not sure what happens.
okay, so why don't we do this? I think I have the slides. Let me try sharing my screen, and then you tell me to go ahead with the slides.
Yeah, sure. I don't know what's going wrong now, but
That's okay. I think. Um, yeah, I have the slides. Let me download it also.
in the meantime, one second, let me try to share my entire screen. And do you see my whole screen now?
No.
Even from browser?
No.
No, sir.
Well, I think there is something wrong at the back end. Probably.
Okay, I'm sharing my screen. So,
Please, yeah.
can you see my slides?
Yeah,
No.
please make it full screen.
Yeah, I'll do that. But
Yes,
so that
ma'am.
let me also get a confirmation from
Yes, sir.
people on
Yes, sir.
people on YouTube. YouTube, can you confirm if you're able to see the slides?
On Teams, it has come.
I'm sharing.
It will go live. Huh. It has come now, sir.
Okay, so let me put it on slideshow, and we can speak. You can move the fourth slide. Okay, 1, 2, 3, 4.
A couple of more clicks, please.
Is that okay?
Yeah, this one.
Yep.
Yeah, I think I got interrupted when I was mentioning about the importance of ionosphere, which is particularly very important for radio communication. So, could you please go to the next slide?
Yeah.
So, as an analogy, if the ionosphere is smooth, it's like seeing our face in a mirror. So, we can decipher the information that is coded in the radio waves. But if the ionosphere is not smooth, if it is irregular, we get something like a reflection from a broken mirror. That's what I have given here. And similarly, thermosphere is very important as well. The satellite drag will change significantly based on the density of surrounding air. You might have heard a couple of years ago in February 2022, SpaceX lost about 40 satellites of their Starlink network during the launch. That happened because, as a weird coincidence, a minor geomagnetic activity was started at the exact time when they were releasing the satellites. And they didn't expect it, and they thought the thrust power that they have in them will be enough to put them in the orbit, but then apparently it was not the case. See, the point is that therefore we should have a better understanding of the upper atmosphere, and it's not that it's just a pure academic pursuit, and it also has applications, but at high tech and high end area. The last figure that I have shown is very important for high latitude. What happens is ionosphere has current systems. So these currents will induce inductive currents in the long conductors in the air. So two main long conductors are nationwide power grids where we have power lines that are above the surface nationwide, and the underwater oil cable, oil pipes. So these oil pipes and power grids can have induced currents on them, and it is very dangerous for the oil pipelines because that will aggravate the rusting that will degrade the pipelines. Next slide, please. So in my present proposal, I'm going to study the early morning atmosphere. But before going to that, I'm just showing what are the more important low and mid latitude features in the ionosphere. So there are two equatorial electrojet and positive current system. Sporadic is accumulation of charged particles. I mentioned about meteors that deposit extraterrestrial material, and they have some metal ions like iron, sodium, and so on. So these ions will cause strong accumulation of charged particles that can affect the radio waves. And ionization anomaly is a feature that I'm showing in the bottom third figure. where you find a high ionization on both the sides of the diffuser that is represented as a thin white line in the center. So that is unexpected because we expect the ionization to peak in the equatorial region, but it was resolved about 80 years ago. That what we found is there is electric fields in the ionosphere and it distributes the plasma. So MPM and MPB are something called midnight temperature maximum and midnight pressure belts. So what happens is the overall upper atmosphere expands in the sunlit side and it contrasts towards the days, towards the midnight sector. So that causes they have tidal modes and all, and that causes something called midnight temperature maximum. Spread up is the very important. In the previous slide, I showed the disturbed ionosphere and the analogy. That kind of a situation is often triggered by the ionospheric instability that are typically referred to as spread out. The pre-reversal enhancement is a unique thing that happens around the sunset terminator. So this is very relevant to the present ANRF project that I'm going to investigate on. So we have well understood the pre-reversal enhancement, though there are different mechanisms that are proposed and their relative importance is being understood. Please go to the next slide. But what is not known, not well understood is while sunset terminator is reasonably well understood, we do not know much about the early morning hours, especially what happens after about 2 or 3 a.m. in the early morning local times, after we see the midnight temperature maximum at times and on. And what we do not clearly know yet is there a similar phenomena like pre-reversal enhancement in the evening time? Is there a similar phenomenon at the morning time? There are conflicting reports. Of course, this is not that it is not at all addressed, but then the reports are conflicted and it is not yet a settled issue. But still we have models and we go on and so on. But then if you don't know such a fundamental information, despite 8 decades of atmospheric research, that's still not very good for prediction capabilities and so on. That's the origin of this proposal. So there are three questions that I'm proposing here. One is, of course, to see if there is a zonal electric field. The second one is to see if there are after effects of the passage of midnight temperature maximum. The third one is to study the decay of the plasma instabilities at the early morning hours. Very often they do decay, and it's important to know about them as well. Could you please go to the next slide? So quickly. So this is the proposed plan, the flow chart, and some identified data sets. So we are going to run these as a predominantly available data oriented project, and we are also planning to collect some data sets from PI University as a part of ANR of support. We have an instrument that I'm going to show now, and then we also once we get some output, we will compare it with the empirical model outputs, and then we come up with our solution problems that we can propose. So next slide, please. So regarding associated experimental activities, those ones you are seeing in the left are the GNSS receivers, multi-frequency receivers. The antenna is shown in a separate picture there, and then the shown as the adjacent one in the left side. So this receiver can give total electron content of ionosphere. So it is installed a couple of months ago, running now. We already operate a VLF receiver. The other experimental activity we are doing already is development of low-cost cameras. There are very sub-visual threshold, very faint spectral emissions coming from upper atmosphere. By measuring them, we can understand a great deal about the region, especially about ionospheric instabilities and waves. So the picture that I showed there shows the camera, and the camera is this. So if you are the size, this is the size of the camera, and of course it will be controlled by a Raspberry Pi computer, and we are working on the enclosure and the backend software and so on. So one good thing is for some airflow emissions, especially for OH airflow, which can capture the waves that happen at a lower height of say 80 to 90 kilometers. This has already shown first light, and the experiment was successful. Now I am trying to expand it to other airflow emissions. Next slide, please. So the expected outcomes, of course, we expect to get a better idea and better knowledge on the atmospheric thermosphere systems. And this knowledge will have, as I said, it helps the high-tech space industry, and that way it will have a societal implication. It's not direct health as if health oriented research or something, but then it is relevant to society, and it has benefits. Other major importance I find with such funding is the capacity building and the outreach capabilities that it motivates students to take the project. For example, this instrument, which is only installed a couple of months ago, but then I have already started to incorporate that instrument in my teaching coursework. So this happens very often in an educational institution. That way, this funding helps our strengthening our research area, also helps in the outreach and student projects and care and so on. Thank you very much. The next slide is probably that's the end. Yeah. Thank you very much. So I have given my LinkedIn and email ID in the very first slide. So please feel free to contact me if you are a student or consultancy, whatever it is. Thank you.
Okay, let me stop sharing. You're not able to see the slides anymore?
Yes, at least I am.
Okay, very good. Thank you, Bharat, Yanagan, for giving your side of the content. I saw some questions on YouTube. We can take some. I think there are some of them are fantastic questions. I think there's an ID handle which is geography QA. I think I just hope that it's a real human being, not a bot. Right? Geography QA, I assume, is inspired by question answers. So I think in some order, the questions have come in the same order as how the presentation was done. So let's take some questions for one question at least. Let's do for Bharat to start with, right? So Bharat, you're able to hear me, right?
Yeah.
Yeah. Okay. So I think the question is minimum number of years data required to predict the future, and how long number of years we can predict. For example, 30 to 40 years daily data. How long is the how long future can be predicted?
Yeah. So I answer the second part first. So this is this whole frame about it's weather forecasting. So we are really talking about predicting the weather on the scale of days. We want to know short term and long term in this case is like, more than 2 weeks, 3 weeks, and that's already a hard problem. So in terms, when you talk about predicting, knowing the weather in terms of 30 to 40 years, like many years in the future, then you actually go into the realm of climate projections. And then a lot of other things come into play, like, economic policies, and whether you have invested in renewables and these kind of things. So that's really that's outside the domain of weather prediction. About the question regarding the minimum number of years in terms of training data, the models that I showed in the scorecard, the really popular models like GraphCast and Pangu and Aurora, which by the way are developed by companies like Google, DeepMind, Huawei, Nvidia, and Microsoft. Um, uh, they were trained on 40 years of data from 1979 to 2018, and they have already been outperformed the traditional weather model. I think if you go below 40 years, probably the performance would degrade, and you can of course take more. What I would like to add is rather what people have found is rather than having more years of data, what was really important to have more valuable. So if you had 40 years of data, but you chose a smaller set of variables, it turns out that your performance degrades. So having more variables somehow informs the model more about the correlations between the spatial-temporal correlations between the variables, and you end up making a better prediction for every variable.
Okay, so very nice, Bharat. Very nice. I think that captures both sides of the question. Again, for the audience, if you have any follow-up questions, feel free to ask. And I also see questions coming in. Feel free to ask. And just as a request, if you are listening and if you think that this kind of content is useful, I'm going to use a very cliche line that YouTubers say. click the like button or a thumbs up button on the YouTube video, right? Yeah, let's take one more question. I think this was for Narayan because it came at the end. So let me post the question, and then Narayan, you see what is this relevant to you to start off with. And also, when you're asking the question for the audience, if you can put the name of the speaker, that will also be helpful. But otherwise, I will definitely ask the question. So, what is the resolution of the final output, Lakshmana? And that's the question, which is when you find the results, what is the resolution of the final output?
I believe probably they're talking about the camera because resolution, every time resolution of the camera.
Yeah.
So these cameras are something like 1 to 2 megapixel typically.
Okay.
So it is like 1100 by 850 or something of that range. 650 or 850. So something of that range.
Okay. Sure.
So
Thanks.
that's the spatial resolution.
Yeah. So let's go to Yansini. I have one question for you. This is not from the chat. This is a question from me. So you actually proposed that you are going to create one sort of say value metric that would compass all of the features that you're looking for. So have you thought about the sort of say errors or challenges in having this one metric which takes all of this? Because generally having these kind of one metrics also has problems in terms of how much can it capture, right? So do you have any thoughts on that?
Yes, sir. I will during my data normalization, I will put all the scale data to 0 to 1 scale, and then the final output will be 1 or 2 kilometer resolution map will be prepared at my feasibility, and it will be managed through data normalization process.
Okay.
And also PCA and ASP also will be do this process.
Okay, sure. Let's go to Better. I think this question is for Better. How, again, from the audience, how does the climate change induce non-stationarity in historical weather data affect the reliability of the deep learning? I think this is too heavy, but yeah, that's the question. How does the climate change induce non-stationarity in historical weather data affect the reliability of the deep learning models that we talked about?
Yeah. They would sort of degrade in performance as you move away from the training data period. So this has already been shown, like as a small aside in one of the papers, where they basically what they did was they did 2 training experiments. In one training experiment, they used training data from 1979 to 2018. And another one, they used 1979 to 2015. I think they left out the last 3 years. So in the second setup, the training data was a bit further away from the test data. The test data was, I think, 2020. And when you had more separation between the training period and the test period, that led to a lower performance. So in the face of climate change, I mean, this will sort of have effect on the performance. The solution to that would be to sort of keep retraining the models as and when more data comes in.
Yeah, so the one question that had connection to that was again for audience if you want to follow up with any questions feel free to ask. But a question that I had, Pranita, was that so when you had the slide with the different models listed, which are weather models, I mean, is a generic model also because I did not see anything like a GPT, Mistral type of a list there. Is that how it is done? You take only weather models to compare, and or if you take a generic model and just do the same sort of say task or evaluation, how would it look?
So the thing is, you can't, for example, use just a text model out of the box, right? Because this is a computer vision task. We have you can think of these like we have temperature images of the whole globe as slices, and then we have pressure images, and we want to predict. It's like a video prediction in some sense.
Yeah, sure. But let's do a VLM. So let's take a visual language model.
I think they don't do as well out of the box because I think I'm sure we could have seen them.
Yeah.
So we do have like the Pangu, Aurora, Pangu and Aurora have vision transformer backbones. Right? All right, so they do have models that use attention and so on, but then the attention mechanism needs to take into account like, okay, we have space and time, and these correlations behave differently. So we add in some specificities to this problem, and then you end up with something which is custom made.
No, I think yeah, fair enough, fair enough. Let's go to Narayan. So one question that comes up also is that I mean you seem to be saying that this problem is important, this problem is necessary to study now. But I was also curious about how come nobody has actually looked at these kind of problems until now?
Well, thank you for raising the question. It's not that nobody has looked into. As I showed in the slide, there are few studies, but it's conflicting. The problem is not settled. Given that we have the evening hours, we have sunset temperature is intensively studied, and the reason comes from the application-oriented nature, because they generate plasma instabilities and that affect radio communications.
Yeah.
But early morning ionosphere is usually quiescent, so there are no direct. Probably my impression is that there are no direct such kind of radio frequency disruptions and so on. So probably this was not receiving the same attention as the sunset terminator. So sunrise terminator is not receiving the same attention. The second problem is measuring early morning ionosphere is very difficult because of reduced electron densities. So usually ground-based methods do not give sufficient information, and they widely use the instrument called ionosonde that mostly will not receive echoes after say 3 o'clock in the morning. So there are a combined set of reasons, but what I realize is probably there is enough for separate data set, and if we mix it with some selected ground-based measurements, we will be able to tackle this question. So in part, I am also probably lucky.
No, I think yeah, sure. I don't know for Benatas and Yamaseni's work, but it's always nice to see these physical pictures of data collection and all that. No, fantastic. I think if I end up being at Korea, I'll definitely want to see the setup.
Yeah, please.
But here is a question to Yamaseni. Two, I think one is the question from the audience, and one question I have. The question is, will the data like night light data be shared with organizations like PMHS, helping migration of birds? Will that help? Is that question making sense, Yamaseni?
No, it is night data actually showing the urbanizations and all the basically transformation of habitat human activity and infrastructure expansion, because the satellite gets the data in the night time.
Right.
It cannot be helpful for the BNHS people.
Oh, okay, fair enough. My question to you was, so you collect a lot of this data. What are the scientific, probably statistical methods that you sort of say use in terms of checking the validity of the data that you're collecting? I mean, how do you make sure that the data that you collected is good?
I will do my once the outcome map will be published, prepared. Then I will do the ground truthing verification of the vulnerable sites of the whole India. If the area is that I will face that basically the inaccessible area which I cannot reach there, then I will use the Google Earth satellite image, otherwise the planet high resolution planet platform satellite image for the data validation process.
Okay, very good. So one common question to all three of you. Let's go in the same order as we presented. All three of your projects have skills that are possibly not going to come from one discipline directly. Student, let's take if I'm a student. What skills are you looking for from me when I send you an email or reach out to you saying I want to work with you?
For me, it's basically interface between you could have, let's say, one set of these students be willing to sort of indulge with me to learn something about the other set as well. And that, I think, is what I look for essentially in a student.
Sure, sure. Let's come back here again, Sally.
For my study, I basically searching for remote sensing and GIS technique persons and statistical.
Yeah, programming, preferably Python or MATLAB. So if they have that programming, because otherwise you cannot handle this kind of things.
Okay.
So
Yeah, that's where I was going to go to for both Benita and at least to understand. Would you, I mean, try and explain this, statistics, things like that. But it's okay. I think okay. So one is use of Google Earth Engine free or need commercial subscription. Does anybody have any idea of that? Which is if you have to use a Google Earth Engine for a government project, should it be paid? And I think my recommendation I would say is that I think it depends on the project. It depends on the yeah, good.
Yes, I hope the
But tuning to reflect on if they have any questions for the speakers. Uh, if you bump it up, it may be just missing in the chat. That's all. I'm happy to actually take the question. Okay. I mean, plus now everybody's asking, right? What is the compute level? What GPU do you need? Can you give us some sense of for your research? What compute do you need?
Um, uh, you do need uh, sort of a high performance GPUs, so not the kinds that are typically like not these RX NVIDIA RX series that you get on laptops and stuff. So these models, so basically the series of GPUs that I'm exposed to is like are the NVIDIA V100s, and then following that comes the next series A100s, and the most recent one are the H100s and the H200s. Uh, uh, it's possible. I mean, if you have the latest, that's of course it's great, but I think the first model that was released, which was in 2022, ForecastNet, that was trained on V100s, which is already like, I don't know, several generations old now. So if you have a couple of V100s, it's going to take some time, but you can train your model. Sorry, I can't hear.
Sorry. I was making a comment that compute is the thing that everybody is talking about. So I think it's good to know what level of compute are you looking for.
I just it occurred to me one point that is important to note is that if you remember, I talked about like these 70 variables, and that's basically 70 images, and each image is like a million pixels.
Yeah.
So that is actually something more to be aware of, that you want to load this weather state into memory to sort of pass it through the model. And most models actually try to load two weather states, today's and yesterday's, to predict tomorrow's.
Yeah.
That in-memory usage, the memory size of the GPU cards, that's a limiting factor actually, rather than the speed.
Okay, very good. So yeah, I was thinking one question for you is, so I think you briefly said somewhere, but I just wanted to explicitly get your thoughts on, keep it short. In terms of challenges in the data collection that you have.
During satellite data imagery data collection, I'm not getting any challenges because all the data sources are freely available, and I'm downloading from Google Earth Engine portal, so software, and also the analysis part will be done with also ArcGIS Pro and Google Earth Engine. Because Google Earth in the Google Earth Engine software, the data downloading process will be faster than other source. Then challenges will be faced during the ground truthing only, not collecting the database.
Okay. Okay, fair enough. The validity part that we talked about before, yeah.
Yes.
Yeah, sure. So Narayan, question for you is this. So you talked about this decay, and you also gave some examples in the real world of something happened, SpaceX. So this decay of instabilities, right? Why is it important to study? I mean, can you throw a little bit more thoughts on why is this so critical to study?
Yeah, thank you very much. I think that's a very thoughtful question because formation of instabilities are important. That are going to affect the radio wave communications. The question I think is why decay is needed to be studied anyway. Decay.
Yeah.
But what happens is these instabilities they actually go for very large sizes, something like of the order of hundreds of kilometers, and they reach very high heights in the ionosphere, more than 1,000 kilometers.
Okay.
Once they cross about 700, 800 kilometers, ideally what physics tells us is that they will not be easily refilled and ionosphere should not be uniform in the next morning. But what we find is it's very rare that they sustain to the next morning. Of course, very rarely sometimes they do. But for the number of times that they form and they reach high heights, they don't really sustain into the early morning. That means they do decay. The whole structures that are caused by the instabilities do decay within the night, and it is important to study how they happen. And we did a first study on that aspect, and we found that these instabilities come to lower heights in the night time itself. But in that study was, I'm with this project in the early morning hours, I want to continue on the line.
Right.
It is important to see why they disappear in the night time itself.
Very nice. Thank you. Thank you, Narayan. I think let me give you 30 seconds to all of you, three of you. Any final thoughts?
Yeah, thank you for the project. Sorry, I'm going first. One other thing I want to point out is yes, project is for 3 years, but the instruments that we get are going to support the science for a longer period. So that's a very important point why such projects and such fundings, generous fundings are very important. I'm very glad that the ANRF is now, it looks to me like a leap from surf. So I'm in the right direction. Thank you.
No, I think you mentioned this on the slide also, which is very good. Yeah, very nice. Yeah, but Jansen, if you don't have anything else, that's fine. We can move on. Okay, pretty good. Pretty good. Thank you, everyone. I think the questions in the audience also has talked. Thanks audience for joining. I think one interesting thing from the three sessions that we have done is this time the questions quality was very high. Thanks to Geography QA, I guess. Geography QA, whoever it is, helped the session to be more technically relevant. I think the questions were very, very high quality, and there was also less noise in some sense, which is very good. Thanks again for joining for the audience. Thanks to the three speakers today. I think it's always nice to hear people doing this very diverse thing, interesting problems, has some societal impact on that. Fantastic. If by any chance I'm in the city that three of you are in, I would love to catch up in person and see what you're doing. Okay. Thanks again. I will, Sumita, if it's okay, can you stop the
Sure.
YouTube live? And then,
Sure.
Sumita, we can't hear you, but yeah, I'm assuming you're stopping.
Good.
Okay, let me just double check that.